We will now begin Chapter 25, which concerns electric current and resistance. We're all familiar with electric current because it flows through wires and powers our appliances and other household items. This first module is 25.1, where we introduce the concept of the electric current. If we take any object and attach a voltage across the two ends, that is a potential difference, so there's a certain voltage between here and here, charges will try to move. If this is a battery, we might represent it by the symbol for a battery, which looks like this. This might be a 12-volt car battery, for example. And we attach the ends to here, and of course this is normally thought of as the negative end. This longer mark is thought of as the positive end. So this end is positive, and the electrons will try to flow in this direction. Actually, the current will flow in the direction of positive charge, which is in this direction. So this will be the direction of the flow of current. So this flow of electrical charge that occurs within a substance is called an electric current. Electric current is the amount of charge, formally defined, we use the symbol I for current, sometimes a small I, is the number of charges in coulombs that flow past a given point in a second. So it is the change in charge divided by the change in time. In other words, coulombs per second. And coulombs per second is a new unit which we call the ampere, or sometimes just simply the amp, and sometimes abbreviated just with a capital A, just like coulombs abbreviated with a capital C and seconds with a small s. So if we have a problem where 40 coulombs flow in this wire past a given point right here every 10 seconds, then we have a current, I, which is 40 coulombs per second, which is going to give us 4 amps. So that's pretty straightforward. Of course, if you define this in calculus, where the current's constantly changing, you could write I as dq over dt. In other words, the derivative of the charge per unit time that's flowing past a point. Again, the ampere is a coulomb per second, or we write A is equal to C over S. You're responsible for understanding that the ampere, or the amp, is a coulomb per second as a unit, and the definition of the ampere as a unit of current as the change in charge per unit time. Okay, that pretty much gets our introductory module.